Hello and welcome to space, and this month we're talking about food. These days, when you go to orbit and you're an astronaut, the kind of thing you're given to eat looks like this. It's pre-prepared on Earth and then sent into space on a rocket. It's very nice, but what if you want to go on a long-duration flight? To do that, you might need to produce some food in orbit and make some air to breathe. Can it be done? We're here in Bremen and in Barcelona to find out. It's not easy to produce food in space, but it can be done. Russian cosmonauts first ate experimental space crops in 2003, and last August, American astronauts snacked on their first space lettuce. But spacefarers need much more to survive. Exactly how much has been precisely measured by a team supported by ESA.
The basic figures that are used are 5 kilos per astronaut per day in terms of metabolic consumption. So that means 1 kilo of oxygen, 1 kilo of dehydrated food, and 3 kilos of water, which are used as drinking water and to hydrate the food.
There are several projects underway to try to meet those different needs, including this experiment with rats and algae in Barcelona. It's part of the Melissa consortium, whose aim is to develop closed-loop life support systems for space travel. Here, the rats breathe oxygen from the algae, and the algae breathes CO2 from the rats.
The rats, by breathing, are producing the CO2. The microalgae, they capture this CO2, and with the light in the photobioreactor are able to produce the photosynthesis, so producing oxygen, and then the oxygen goes back to the compartment with the animals, and this is done in a closed loop continuously.
One of the great challenges the Melissa team has overcome is developing a system to almost instantly increase oxygen production from the microalgae.
The illumination of the photobioreactor is more intensive or less intensive depending on the amount of oxygen that is required by the rats.
Meanwhile, German space engineers are building a satellite to grow tomatoes in space. The Eucropis spacecraft will launch next summer and will spin around the Earth as the seeds germinate inside.
We have a greenhouse which is growing tomatoes on the outside shell of the satellite, and when we rotate the satellite, then we introduce different gravity levels on the outside of the satellite. And that's how we try to simulate the gravity on Moon and on Mars.
Next door are the space botanists. They prefer plants with a high ratio of fruit to plant mass, and they chose tomatoes for Eucropis for a simple reason. The red fruit is easy to spot on camera.
This is the Eden Laboratory here in Bremen from the German Aerospace Center. We are investigating the techniques around plants, so controlling humidity, controlling temperature, fertilizer solution, and so on. How to grow plants also on different planets, so for exploration of the humankind. This is microtina, really fast-growing, fast-flowering, fast-fruiting tomato, and in these experiment here we are checking, it's a control experiment, we are checking the crop solution for fertilization these microtina tomatoes.
It turns on.
When it comes to fertilizer, the space tomatoes will be watered by a natural byproduct of astronauts.
Yellow element for your number one.
We're using urine. So urine is really, it's like yellow gold for plants. Science, and also when you're producing food for humans in closed systems on Moon or Mars.
The plants won't grow on soil in space, it's too difficult to manage, but the spin of the spacecraft should give the seeds a good idea of which way to grow roots or leaves.
We found that a plant needs only 0.1 G for sensing the bottom or for sensing the direction. So it's enough also on Moon and on Mars. Here we have different boxes or different rooms. This here was microtina tomato. This one here is a bell pepper, and here we have some cucumber. Don't eat it now because it's a scientific grown cucumber, but I can tell you it tastes great.
Back in Barcelona, the Melissa Consortium's next goal is developing methods to recycle solid and liquid waste from plants and animals. They're convinced that closed-loop systems are essential for long space flights.
I think it's doable, and I think it's necessary.
Growing plants in space is something we have to do. The longer the mission is, the more necessary it becomes. From the moment that we can't bring along all the food requirements of the astronauts, we have to find a way to produce this food.
Food grown in space could one day make up a quarter or even a half of daily astronaut needs, while oxygen loops and water recycling rates will climb much higher. Just in time, perhaps, for the first multi-year deep space mission. Away from rats, algae and tomatoes now, and to our regular update from the ExoMars mission, which we're following all year on space. We asked one of Europe's leading planetary scientists where he would look for life on Mars.
Bonjour. Hello, I'm Jean-Pierre Bibring. I'm in charge of one of the instruments that will analyze the samples that will be collected by the ExoMars rover. With ExoMars, what we're trying to find out is if, early in the history of Mars, there were conditions that allowed life to emerge, just as it did on Earth in the same period, from water and molecules brought from elsewhere. On Mars, there are 2 ice caps, and Mars rotates in just over 24 hours. There are huge plains in the north and large plateaus in the south, which are several thousand meters high and covered in impact craters. And between the two, there's a transition zone where we can get to land, which is even older than the plateaus, which are 4 billion years old. And we're convinced that if life began on Mars, that's where you should look for it. The hope is not to find a living organism directly, but if we find the precursors to living organisms in the form of macromolecules, it will already be a huge step, because it would mean that life is sufficiently robust to have adapted to the Martian environment. What's marvellous is that Mars has preserved the memory of the times when this emergence of life may have happened, and that's what we'll look for with ExoMars.
That's all for now. I'm going to enjoy some of this space food. You can watch other episodes of Destination Mars and keep up to date with space news on our website. See you next time.